So we're going to move on in our understanding of bonding. We've been looking at giant ionic bonding. That's the bonding between a metal and a non-metal. And in that type of bonding, we had metals losing electrons and non-metals gaining electrons. Why were they doing this? They were doing this because they wanted to achieve a full outer shell. So really that is the aim of bonding. Bonding is all about atoms achieving full outer shells, and there are various ways they can do that. So this type of bonding is called simple covalent bonding. So this type of bonding is not giant, it's simple, that means something else. It's not ionic, it's covalent. And this type of bonding occurs between two non-metals. And as we just said, the non-metal is the atom that wants to gain or accept or receive electrons. So this is interesting in that the atoms in this type of bonding are all trying to gain electrons to get a full outer shell. But there's nothing that's giving away the electrons. So they've got to work out how they're going to get a full outer shell when the atoms both want to gain electrons. So what they do is they don't lose or gain, they share electrons. And they always share electrons in pairs. If one gives one electron into the shared area, another atom will give an electron into a shared area. So when these atoms share their electrons, they form molecules. Molecules are little bunches of atoms, little groups of atoms joined together. So I guess the smallest bunch you might ever find is a bunch of two. You perhaps might not say bunch of two, but we'll say bunch of two. So F2, that's a little bunch of two fluorine atoms. So along come the two fluorine atoms. I'm going to do one in black. I'm going to do one in another colour, just to distinguish them. And if you look at the periodic table, fluorine is in group 7. So because fluorine is in group 7, and it wants to get a full outer shell, it will need to share one of its electrons. And because it shares one of its electrons, that means it will have left over 6 of them that are not involved in bonding. Let's go through that again with the other atom. Fluorine is in group 7. Because it's in group 7, it will have 7 electrons in its outer shell. Because it's in group 7, it would like to have a full outer shell, and fluorine shell is full with 8. So therefore, it needs to share one more electron. And that means left over, there are 6 electrons that are not involved in bonding. Now, when the atoms share, the actual outer shells of the atoms overlap. And there's a nice big communal area in the middle. So there's one fluorine, and there's the other fluorine. So when they overlap and they share, they put the one electron that they're sharing into the middle, leaving the other 6 sitting on the outer shell. What you have to remember is this is only the outer shell of electrons. So there are more electrons in fluorine. They're sitting in the inner shell. You might want to work out how many more electrons there are in fluorine. But only the 7 in the outer shell are we showing here. Now let's look at the other fluorine atom. It also puts one of its electrons into the shared area, and therefore it's got 6 of the others left. So that is now how we represent the covalent bonding. We show 2 outer shells of the atom overlapping. We show the shared area. 1 electron from each atom is shared in the middle, and we end up with a shared pair of electrons. Notice that I used dots for one atom and crosses for the other. You don't have to do this, but this is a really good way of showing which electrons belong to which atom. Now there's another way that we can represent that sharing. We can say that F is forming a covalent bond with another F atom. with another fluorine atom. And now they're forming that molecule F2. That line or stick between the two fluorine atoms is sometimes called the single covalent bond. Okay, now we're going to move on and we're going to look at another type of molecule. This type of molecule is called O2. So this type of molecule has got 2 oxygen atoms in it. It's again a small bunch. So I'm going to represent one oxygen atom by a blue O and one oxygen atom by a green O. So remember, first of all, we have to think they both want to share electrons. How many electrons do they share? So the first thing we have to think of is what group of the periodic table is the atom in. Remember, these are all non-metals, so they're all going to be over on the right-hand side. So oxygen is in group 6. Therefore, in order to have a full outer shell, it needs to share 2 electrons, and therefore it's going to have 4 left, 4 not involved in bonding. That will be the same for the other oxygen atom. The other oxygen atom is in group 6. It will want to share 2 electrons, and therefore it will have left 4 electrons which aren't bonding. So again, we overlap the outer shells. We have a communal area in between, and we start to put the shared electrons into the communal area. So the green atom, that will share 2 of its electrons. Because there are 6 to start with, that means that there are 4 left over. 4 left over in that oxygen atom that aren't bonding. Now if we look at the other oxygen atom, that's also going to put 2 electrons into the shared area, and therefore it's going to have 4 electrons left over. So when we look at how many this atom is sharing, there are 2 shared pairs of electrons. And we can use the stick model by drawing the 2 O's joined together. Now this time we show 2 lines in between the 2 atoms because each line is representing one of the shared pairs. This is called a double covalent bond. The final thing we just have to remind ourselves of, and just to check, is actually how many electrons are in the outer shell of each atom. So if we have a look at the first oxygen, we can see that we have got 2 here, 4 here, 6 and 8. So this oxygen atom has got a share of 8 electrons. Admittedly, they're not all its own, but it's sharing or has a total of 8 electrons. If we now look at the other atom, it's got 2, 4, 6, 8. It's also got a share of 8 electrons. So both atoms have filled their outer shells. Okay, let's have a look at a slightly more complicated molecule. Let's have a look at SiH4. Now you might be thinking, oh, how do I name that? That's silicon and hydrogen. So that is a bunch with 5 atoms in it, 4 hydrogen atoms and 1 silicon. So remember, we put them side by side. You can use different colours if you want to. One's hydrogen and 1 silicon. So we have to think, what group of the periodic table is silicon in? It's not a particularly familiar atom, but it's in group 4. And therefore, how many electrons does it need to share in order to get a full outer shell? Well, remember, it needs 8. So in order to do that, it's going to actually have to share all 4 of its electrons, which means left over, it will have none left. Hydrogen is an inner group. It's a special atom, and therefore we can't really talk about its group, but it's only got 1 electron. And because it wants to get a full outer shell, its outer shell is filled up when there are 2 electrons. So it needs to share its 1 electron, and therefore it's also got none left. Now, when we look at the formula, we've got 1 silicon. So if you've got 1 silicon, I'm actually going to put that 1 silicon in the middle. And that 1 silicon has to join with 4 hydrogen atoms. So I'm going to put 1 here, 1 here, one here and one here. Now remember, the hydrogen atoms, they can't overlap. They're just joining with the silicon. So it doesn't matter where you start, but I'm going to start with the silicon first of all. Silicon has got 4 electrons. So I'm going to put one of its electrons there, one there, one there, and one there, because it's sharing with 4 hydrogens. Now, because I've put 1 electron in from silicon, I have to put 1 electron in from hydrogen. But that's okay, because hydrogen has only got 1 electron. Once I put 1 electron in for each hydrogen, there are no more left in the outer shell of hydrogen. Also, there are no more left in the outer shell of silicon. I've used all the electrons in bonding. So now, if I say, right, well, how many shared pair of electrons are there? I can see there are 4 shared pair of electrons. But between each silicon and the hydrogen, there's only 1 shared pair. So I've got a silicon with 1 shared pair to a hydrogen. I've got a silicon, the same silicon, with another shared pair to a second hydrogen. I've got the same silicon with another shared pair to a third hydrogen, and the same silicon with another shared pair to the 4th hydrogen. So we've got 4 single covalent bonds. They're single covalent bonds because we're only sharing 1 pair of electrons. Between each silicon and hydrogen.